Welcome, everyone, to TechDaily.ai. I'm your host, David, and joining me today to unpack this massive shift in the IT landscape is our resident technology expert, Sophia.
Hi, everyone. Glad to be here. We've got a lot of ground to cover today, and I think the mechanics of this are going to surprise a lot of people.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit TechDaily.ai to get started today.
So to jump right into it.
Yeah, let's talk about the servers. The physical machines running your favorite streaming apps, securing your banking records, hosting company databases. They're currently caught in the middle of a massive industry shakeup.
They really are. For over a decade now, these proprietary virtualization giants, companies like VMware, mostly have essentially treated the data center as their own personal kingdom.
Right. They set the rules, they locked organizations into these rigid software ecosystems, and, well, they dictated the prices.
Exactly. But that walled garden is, it's developing some serious cracks. We're seeing a major migration right now.
Because IT teams are realizing they don't actually have to pay those exorbitant licensing fees just to manage their own hardware, right?
Right. An open source challenger has entered the arena, and it's completely reshaping how organizations build their infrastructure from the ground up.
It's proving that community-driven platforms can actually handle enterprise-grade workloads. And that challenger is called Proxmox VE.
Yeah, Proxmox Virtual Environment.
So today, we are exploring exactly what this platform is. We'll look at how it balances running full virtual machines with these lightweight containers and whether it represents the future of your IT infrastructure.
It's a fascinating shift to watch.
But before we get into the weeds of Proxmox specifically, let's lay down a quick foundation for anyone listening. Why is virtualization the absolute bedrock of modern computing?
Well, to really understand the value of it, you kind of have to picture what computing looked like before virtualization.
Oh man, the dark ages.
Seriously. In a traditional setup, you had one physical server running one operating system, and it was dedicated to one specific application.
Which sounds incredibly inefficient.
It was. Most of the time, that physical server might only be using like 10 or 20% of its actual processing power.
So the rest of those CPU cycles, all that expensive RAM, it's just sitting idle.
Yeah, just sitting there, drawing electricity and generating heat. It was a massive waste of resources.
So you're basically paying for this massive V8 engine, but only ever driving it at like 10 miles per hour down the street.
That is the perfect way to describe it. Virtualization changes that math completely by introducing a piece of software called a hypervisor.
And the hypervisor sits directly on the physical hardware, right?
Exactly. It sits on the bare metal and allows you to slice that physical server up into multiple, completely isolated virtual computers.
So you could have a web server, a database, and an email server all running on the exact same physical box.
Right. And they are completely unaware of each other. You maximize your hardware efficiency, you shrink your physical footprint, and, you cut your hardware costs by orders of magnitude.
Which brings us back to Proxmox VE. At its core, this is an open-source virtualization management platform. And it's built on top of Debian Linux.
Which is renowned for being just rock solid and stable.
Yeah. But what makes Proxmox so disruptive is how it handles the orchestration of all those resources. Because historically, in legacy environments, your infrastructure was heavily fragmented.
Oh, totally. You had your compute servers over here running the applications, then completely separate, massive storage arrays over there.
And then a totally isolated networking stack connecting them all together.
Right. You needed different proprietary software and honestly, often different specialized teams just to get those pieces to talk to each other without breaking.
It really reminds me of an old school entertainment center from the early 2000s. Have you ever set one of those up?
Oh, yeah. With a massive tangle of cables behind the TV.
Yes. Where you've got 5 different remotes scattered on the coffee table. One for the TV, one for the audio receiver, the cable box, the DVD player.
And you have to know exactly which input corresponds to which remote.
Exactly. And if one cable comes loose, the whole system just stops working.
That is a highly accurate way to visualize the legacy data center. Proxmox, by contrast, operates on this principle called hyperconverged infrastructure, or HCI.
So to stick with the analogy, HCI is basically like upgrading to a modern smart TV.
Yes. The streaming apps, the audio routing, the screen controls, it's seamlessly built in.
With Proxmox, your compute, your network, and your storage are tightly integrated.
Right, they're all managed from a single unified web interface. You don't need a separate, expensive management server just to oversee the whole operation. It's completely self-contained.
Now, I can hear a skeptical IT director listening to us right now asking a very logical question.
Okay, let's hear it.
If this software is entirely open source, meaning literally anyone can download the code for free, how does it manage to actually compete with billion-dollar enterprise software companies? Like, is it just a hobbyist tool?
Yeah, we see that a lot. People often conflate open source with amateur, and that is just a massive misconception.
Right, because Linux itself runs most of the internet.
Exactly. In the enterprise space, open source represents freedom from vendor lock-in. It means an organization isn't at the mercy of arbitrary licensing walls.
Or sudden massive price hikes at renewal time.
Which happens all the time. Open source allows system administrators to build highly capable, massively scalable systems directly on top of the Linux kernel without paying a premium just for the privilege of turning the software on.
And the code is transparent, heavily vetted by the community.
And crucially, it is commercially supported if you choose to pay for it. You can absolutely buy enterprise support.
That makes a lot of sense. So let's look at what Proxmox is actually managing under the hood, because it offers two distinct tools for virtualization, right? KVM and LXC.
Yeah, let's start with KVM. That stands for Kernel-Based Virtual Machine. This is the heavy hitter of the virtualization world.
Because it provides full hardware virtualization.
Right. When you create a KVM instance in Proxmox, the software is literally faking an entire computer. It emulates the motherboard, the network controllers, the graphics card, the hard drives.
Everything. Which means the guest operating system has absolutely no idea it's virtualized.
None at all. It just looks around, sees what it thinks is standard hardware, and boots up normally.
That's why you can run completely unmodified operating systems on it.
Oop.
Like you could just throw Microsoft Windows Server on there or a specialized FreeBSD firewall.
Correct. But, and this is important, emulating all of that hardware from scratch requires computing power. There is a small but real performance overhead.
Because the hypervisor has to translate every single request the virtual machine makes before passing it to the actual physical hardware.
Exactly. And that's where the second tool comes in, LXC, which stands for Linux containers.
Now, how does a container avoid that hardware emulation overhead?
Well, instead of faking an entire PC from the motherboard up, a container simply shares the host system's existing Linux kernel.
Okay, but how does it maintain isolation without emulating the hardware?
To understand that, we have to look at two specific Linux features. They're called cgroups and namespaces.
Break those down for me. What are cgroups and namespaces doing, in plain English?
Sure. Think of a namespace as solitary confinement for a computer process. It basically places blinders on the container.
So the container can't see the outside world.
Right. It can only see its own virtual file system, its own network interfaces, and its own processes. It has absolutely no idea the host system or other containers even exist.
Okay, that's namespaces. What about cgroups?
Cgroups act as the rationing system. The key group tells the host kernel, hey, the specific container is only allowed to use a maximum of 2 gigabytes of RAM and 20% of the CPU.
Okay, I get it. So by combining the blinders of namespaces with the resource limits of cgroups, you get this isolated environment that feels exactly like a virtual machine.
But it boots in milliseconds.
Wow. Because it doesn't have to load its own operating system kernel.
Exactly. The overhead is virtually zero because the applications are essentially running directly on the host hardware. They're just, fenced in.
Now, it's probably important to clarify here that Proxmox uses LXC as system containers.
Yes, very important distinction. That is fundamentally different from something like Docker.
Because Docker popularized the application container, right? Which is this tiny ephemeral package designed to run just one single isolated app, like just a web server process.
Right. But Proxmox system containers run a full Linux operating system inside them. You can log into them via SSH, manage a standard file system, run multiple background services.
It's like a real server. But wait, let me push back on this for a second. If LXC containers are so incredibly lightweight, fast, and efficient, why would an administrator ever bother using a clunky, full KVM virtual machine? Why not just containerize the entire data center?
It's a fair question. It really comes down to security and compatibility.
Because they share the kernel.
Exactly. Because containers share the underlying host's kernel, they are inherently more vulnerable to system-level exploits.
Ah, so if a malicious user discovers a flaw in the kernel and manages to break out of their container,
They theoretically have access to the entire physical host and every single other container running on it.
yikes. So KVM provides that deep hardware-level isolation.
Right. If you are hosting a multi-tenant environment where clients absolutely cannot be allowed to touch each other, KVM is the secure choice. Plus, because containers share the Linux kernel, they are strictly limited to running Linux distributions.
You obviously cannot run a Windows container on a Linux kernel.
Right. So the rule of thumb is use LXC for trusted, high-performance Linux workloads, and KVM when you need deep security isolation or a different operating system.
Got it. Okay, so now that we have the compute side figured out, let's talk about where all this data actually lives. The storage infrastructure in Proxmox.
It is incredibly flexible.
Yeah, I mean, it supports standard local directories, network shares, but there are two standout technologies integrated natively that we really need to cover: ZFS and Ceph.
Oh, ZFS is amazing. It's a combined file system and logical volume manager that completely changes how we think about data integrity on local servers.
Because historically, administrators had to rely on those expensive, specialized hardware RAID cards to manage multiple hard drives, right?
Yeah, and ZFS does all of that heavy lifting entirely in software, just using the server's main CPU and RAM.
Now, I've heard ZFS praised heavily for preventing silent data corruption. How does it actually do that mathematically?
It relies on checksums. When you write a file to a ZFS storage pool, the system calculates a unique mathematical hash, basically a fingerprint for that specific block of data.
And it stores that fingerprint separately from the data itself.
So later, when you go to read that file, ZFS recalculates the fingerprint on the fly.
So if a hard drive has started to physically degrade and it accidentally flips a single 0 to a 1,
The newly calculated fingerprint won't match the stored fingerprint.
meaning it instantly knows the data is corrupted, even if the hard drive didn't technically report a hardware error. It's like having a magical filing cabinet that constantly reads its own documents, checks for typos, and instantly flags them.
That's a great analogy. And because ZFS is usually configured with parity, meaning redundant copies of data are spread across multiple physical disks, it doesn't just flag the error.
Oh, it fixes it.
Yes, it goes to a healthy drive, grabs the correct block of data, repairs the corrected file on the fly, and serves the correct data to the application.
All without the user ever knowing there was a hardware failure.
Exactly. But, like you said, ZFS is primarily for a single physical server. What if a data center has a massive cluster of nodes and they need storage to span across all of them?
That's where Ceph comes in.
Right. Ceph is a self-healing, massively distributed storage network.
So instead of storing a virtual machine's hard drive on one specific physical server,
Ceph uses an algorithm to crush that data down into smaller objects and distribute them across all the hard drives in your entire cluster.
it's kind of like taking a highly sensitive document, shredding it, and hiding the redundant pieces in different safes across multiple different buildings.
Yes.
So if one building burns down, you can still reconstruct the entire document from the surviving safes.
Exactly. If an entire server literally catches fire and dies, the Ceph cluster immediately notices the missing data objects.
And it just starts rebuilding.
Yeah, it automatically begins recreating them from redundant copies on the surviving servers. It constantly rebalances itself to ensure the data remains fully protected. And it scales up to the exabit level.
And all of this is managed directly from that single Proxmox web interface.
Yep, no extra management servers needed.
It's incredible. And we actually see that same level of flexibility in how Proxmox handles networking.
Networking is a huge part of this. Out of the box, it uses a pretty simple bridged networking model.
Which basically acts exactly like a virtual network switch, right? You plug your virtual machines into this virtual bridge, which routes traffic out to the physical network card.
Right, but for a massive environment, they offer a fully integrated software-defined network, or SDN, stack.
And the SDN stack is fascinating because it allows administrators to build incredibly complex network topologies entirely in software.
Yes. For example, using protocols like VXLAN, you can create a virtual tunnel right over your physical network wires.
Meaning servers sitting in completely different physical racks or even completely different buildings can act as if they are plugged into the exact same desktop network switch.
It provides immense flexibility for, zone-based isolation without having to constantly recable your physical hardware.
Okay, let's trace a narrative here, tying this all together. We have a KVM virtual machine running securely. It's saving data to a distributed Ceph storage pool. It's communicating over an advanced VXLAN network.
The infrastructure is solid.
It's solid, but hardware eventually fails. Hard drives die, power supplies pop. How does Proxmox actually keep an organization running when a critical compute node suddenly goes dark?
It utilizes high availability, or HA, and Proxmox approaches clustering quite differently than some legacy systems.
How so?
Well, many traditional platforms rely on a separate central management server to dictate what the cluster does. If that management server crashes, the worker nodes might keep running, but you can't alter them, migrate them, or fix them until the manager is back online.
Which is a terrifying single point of failure for an IT director.
Exactly. So Proxmox uses a multi-master design to solve that.
Using the Proxmox cluster file system.
Right. It's this database-driven system. It stores the exact configuration for every single virtual machine and network setting in the entire data center.
And the genius part is that it replicates this database in real time to the memory of every single node in the cluster.
Yes. Every server has the complete up-to-the-second blueprint, so literally any node can manage the entire cluster.
So if a node suddenly loses power, there is no panic. The high availability manager on the surviving nodes detects the loss, realizes which virtual machines just went down, and automatically restarts those exact VMs on the healthy servers.
It's brilliant. But this introduces a very dangerous technical edge case called a split-brain scenario.
Oh, right, because what if that original node didn't actually lose power? What if its network cable just got unplugged?
Exactly. It's still running, and the virtual machine on it is still actively trying to write data to the shared Ceph storage.
Oh, wow. So if the HA manager restarts a second copy of that VM on a healthy node?
You now have two identical machines trying to write to the exact same storage file at the exact same time.
Which would instantly corrupt the data.
Complete corruption. Which is why a concept called fencing is absolutely critical here. Fencing is the cluster's fail-safe mechanism.
Basically, before the HA manager is allowed to restart a virtual machine from a failed node, it must definitively prove that the failed node is isolated.
Right. It must be fenced off.
I always think of this like a zombie movie.
Okay. How so?
Well, if a survivor gets infected or goes rogue, you don't just walk away and start replacing them. You have to lock them in the basement first to make absolutely sure they can't harm the rest of the group.
That is, wow. Yeah, that's essentially what happens. Proxmox usually utilizes hardware watchdogs for this. If a node loses contact with the rest of the cluster for just a few seconds, the hardware watchdog forces the server to immediately reboot or just shut down entirely.
It guarantees the server cannot corrupt the shared storage.
Exactly. Only after the node is verified dead does the cluster safely restart the VMs elsewhere. It's ruthless, but it's an entirely necessary mechanism for data integrity.
Definitely. Now, speaking of keeping data safe, we have to discuss security and backup.
For sure. Proxmox includes an integrated distributed firewall that lets you filter network packets at the data center level, the host level, or even right down to the specific virtual network card of a single VM.
But the backup ecosystem is where things get really impressive. Specifically, the Proxmox backup server.
Oh, PBS is a massive operational advantage. Traditional backups often involve copying an entire, say, 100-gigabyte virtual machine every single night.
Which takes hours and consumes massive amounts of expensive disk space.
Right. PBS fundamentally changes that by using advanced data deduplication.
Walk me through how the deduplication actually functions.
Okay, let's say you have 50 virtual machines in your cluster, and they're all running the same Windows operating system.
So they all share identical core system files.
Exactly. When PBS backs them up, it breaks the files down into tiny chunks and calculates a hash for each chunk. When it analyzes the second VM, it realizes, hey, I already have this exact chunk of data from the first VM.
So instead of saving it again, it just saves a tiny pointer referencing the original chunk.
Yes. So instead of storing 50 copies of the Windows system files, it stores one copy and 49 lightweight pointers.
That's incredible. Your backups take a fraction of the time to complete, and you save just terabytes of physical storage space.
And it supports client-side encryption, meaning the data is mathematically scrambled before it ever even leaves the host server.
When you connect all of these mechanisms, the secure isolation of KVM, the mathematical data healing of ZFS, the distributed resilience of Ceph, the multi-master high availability, And these deduplicated backups, you really start to understand why this open source platform is making established enterprise vendors very, very nervous.
It really is.
So let's look at the real world adoption.
Yeah.
With all these features built in, how is Proxmox actually being deployed by teams right now?
Well, the most immediate contrast you notice is the licensing model. With proprietary giants, administrators are constantly managing complex licensing tiers.
Like, oh, you want to unlock a specific storage feature? That's a premium license.
Exactly. You want to add more physical CPUs to your server, that's another license. But Proxmox has absolutely no licensing walls.
Which is wild to think about.
Every single feature we have discussed today is 100% unlocked in the free downloadable version.
Which totally explains why it's wildly popular in the home lab community.
Oh yeah, tech enthusiasts running enterprise-grade data centers in their basements just to learn the technology.
But it scales far beyond that, too.
It does. It's highly attractive to small and medium businesses trying to avoid massive IT budgets. And increasingly, we're seeing it deploy in remote branch offices and cluster data centers where massive organizations want that hyper-converged infrastructure, but without the exorbitant vendor tax.
Okay, but we have to provide a reality check here. I want to play devil's advocate. This platform is not a magical black box, and it surely isn't universally better for absolutely everyone in every situation.
No, definitely not.
What are the main hurdles an organization faces when they try to adopt it? What's the catch?
First and foremost is the learning curve. Proxmox requires a very solid foundational understanding of Linux administration.
You can't just be a point-and-click Windows admin.
Right. You need to understand how the command line works, how Linux network bridges operate, and how storage protocols communicate. It's not a friendly install and forget wizard.
So if something goes wrong deep in the network stack, you are dealing directly with Linux configuration files.
Exactly. And then there's the support model. If a Fortune 500 company has a catastrophic failure at 3 in the morning, they are very used to picking up the phone and having an army of vendor engineers fix it for them.
Right, and Proxmox.
While Proxmox does offer excellent commercial subscriptions that you can purchase, and many do out of the box, it lacks that massive outsourced vendor support safety net.
So if you don't pay for enterprise support, you are entirely reliant on your own internal IT team and the community forums to solve complex outages.
Yep. And furthermore, there are specific workflow limitations. For developers heavily invested in Docker, running Docker directly on the Proxmox host is strongly discouraged.
Why is that?
Because it can actually interfere with the hypervisor's network and storage routing. It messes with the firewall rules. So you have to nest Docker inside an LXC container or a KVM VM first.
Which is an extra configuration step that probably annoys some development teams who just want to deploy code.
It definitely does.
Okay, taking all of that into account, the incredible feature set, the lack of licensing fees, but also the reality of the learning curve, who should genuinely consider making the jump to Proxmox?
I'd say it is ideal for IT professionals, system administrators, and businesses seeking flexibility and dramatic cost reduction. The caveat is that the organization must possess or be willing to actively build fundamental virtualization and Linux skills.
Which isn't necessarily a bad thing.
Yeah.
Honestly, managing infrastructure this way fundamentally makes you a better IT professional.
I completely agree, because it strips away the abstraction.
Right. Instead of just clicking arbitrary buttons in a proprietary system where you don't actually know what's happening behind the scenes, you are forced to understand the architecture.
You learn how the network packets actually route and how the Linux kernel interacts with the hardware. It reveals the true mechanics of the infrastructure.
And looking at the future trajectory of the industry, open source virtualization is becoming heavily relevant. Companies are increasingly terrified of vendor lock-in.
They want full sovereignty over their hardware and their data, and they want to control their hyper-converged infrastructure from the bare metal all the way up.
Well, to quickly summarize what we've unpacked today for everyone listening, Proxmox VE is a remarkably flexible, open-source, hyper-converged platform. It gives administrators the deep, hardware-level isolation of KVM virtual machines right alongside the blinding speed of LXC containers.
And it backs that compute power with the self-healing cryptography of ZFS and the distributed resilience of Ceph,
while keeping the entire operation online with automated multi-master high availability.
It really represents a fundamental shift in how we approach data center management. It proves that a transparent, community-driven foundation can rival, and in many technical aspects even exceed, heavily licensed legacy software.
I want to leave you with a final thought on that massive industry shift. Consider just how much of the modern digital world is currently locked behind closed-source proprietary hypervisors. What would global digital innovation look like if the foundational virtualization layer of every single data center on Earth was completely transparent, open source, and accessible to anyone wanting to build the next big thing?
It's a profound question, and platforms like this one are actively building the framework for that reality.
They certainly are. If you want to keep exploring topics like this and continue expanding your technology knowledge, be sure to visit TechDaily.ai for more incredible content. Thanks for joining us, and we'll catch you on the next one.